The Moai stands as one of the most massive achievements on Rapa Nui. It reaches nearly 10 meters in height and weighs an estimated 80 tons, roughly the weight of a fully loaded Boeing 737, while supporting a 12-ton stone cylinder on its head. For decades, history books described a construction process defined by environmental destruction. The theory was that the Rapa Nui people committed ecocide, clear-cutting the island's forests to create thousands of wooden rollers so they could drag these statues horizontally across the landscape. But scattered across the island's ancient road network are 62 statues that never reached their destinations. These road moai were abandoned in transit, and their physical features tell a very different story than the finished statues standing on the coast. The discrepancy between these two types of statues suggests that our modern assumptions about the island's history have been looking at the wrong set of evidence. This data reveals a significant structural difference between the statues. While statues on platforms have narrow bases, the road moai were carved with unusually wide, D-shaped foundations that match the width of their shoulders. A 3D point cloud model of these abandoned statues reveals an even more aggressive design feature. The road moai possess a forward lean of up to 15 degrees, positioning their center of mass so far forward that they cannot stand still without support. There is also a final functional detail missing from every statue found along the roads. None of them have carved eye sockets. They were moved as unfinished blocks of stone. Every abandoned moai was essentially an engineered vehicle, a heavy-duty machine designed with a specific type of instability that allowed it to move. This instability is the engine for transport. The severe forward lean pushes the center of mass over the front edge. By attaching 3 ropes to the head, teams rocked the statue laterally. The forward-leaning weight causes it to roll along its curved base, stepping forward. This method relies on momentum and pendulum dynamics, which makes it remarkably efficient. Because larger statues generate more leverage for the rope teams, the biggest moai are actually easier to move per unit of mass. Modern experiments have validated this technique by successfully walking a 4-ton concrete replica using a team of just 18 people and basic cordage. Vertical walking used the stone's own mass to generate motion, representing a sophisticated application of kinetic physics that required minimal wood and manpower. The islanders built a custom infrastructure to support this movement. The ancient roads have a concave U-shaped cross-section that naturally centers the rocking base of the statue, preventing it from drifting off the path during transport. Once a moai reached its ceremonial platform, the transport features were removed. Carvers chipped away at the D-shaped base until it was flat, effectively disabling the statue's ability to rock. This modification shifted the center of mass backward, locking the statue into a stable, upright position. Only then were the white coral eyes added to complete the transformation from a piece of cargo into a living ancestor. By modifying the statues for permanent display, the Rapa Nui carvers erased the physical evidence of the very technology they used to move them. Lifting a 13-ton red scoria cylinder to the top of a standing statue presents a final massive weight transfer hurdle. To achieve this, the islanders used a technique called parbuckling. Ropes were wrapped around the cylindrical hats and pulled from the top of a ramp, rolling the massive stones upward. This provides 2 critical advantages. It reduces required pulling force by 50%, and rope tension creates an automatic brake, preventing backward rolling. Crowned moai were achieved through the elegant application of mechanical advantage, allowing small teams to manipulate weights that would otherwise be impossible to lift. This walking method aligns with centuries of Rapa Nui oral tradition. For generations, the islanders have maintained that their ancestors possessed the knowledge to make the statues walk from the quarry. These accounts were long dismissed by researchers, who assumed an indigenous society could only build monuments by recklessly exhausting their natural resources. The archaeology reveals a history of deep observation and sustainable engineering, using the laws of dynamic balance to move mountains with a fraction of the expected labor. Rapa Nui's Ruckacy is a testament to the power of sophisticated mechanics, where human ingenuity learned to partner with gravity and make the stones walk.